So next week, September 28th. So we are going to have a first quiz from, let me check. Oh, too bad. 10 to maybe 11:30, first quiz. The topic of the quiz will cover from the first class of the semester to whatever we are learning today. So 3 weeks of material will be covered for the 1.5 hour quiz. And for this quiz, you can prepare one page A4 size cheating sheet. Of course, it's one-sided. Just one page means one-sided, right? And there is no limit of font size. But no magnifier is allowed. That means you cannot bring this. This is X. So there's no limit on the magnifier, the font size. So you can write as small as possible. But it has to be readable without the aid of the magnifier. Calculator is okay. You can bring. Also, you can use dictionary is okay. Because everything will be in English, so either book form or electronic form of English dictionary is okay, but no chatting. So no KakaoTalk, no iPhone, no Galaxy, chat, whatever. So, but you can use a calculator in iPhone or in your smartphone. That's okay, as long as you are not using chatting. And dictionary is okay too. What else? Oh, even though this is English class and every problem will be in English, you can still write down in Korean. So Korean is allowed when you write the answering sheet. Of course, English is preferable. Okay, in the past time, previously, I was very strict, so I only allowed English in everything, including your answer. But well, I'm getting old, so I'm a little bit lenient. So if you're not very comfortable writing in English, you can write in Korean. But still, I preferably in English. So 90 minutes quiz, and it depends on the problem set, maybe 150 to 200 points. So before I proceed, if you have any questions, you can ask. You can even ask in Korean. No question about quiz? And no midterm. Okay. We are only going to take a quiz, maybe two or three quiz and final, but no midterm. Midterm is 중간고사, so there is no 중간고사. And actually, my most preferable date for quiz is October the 13th. Anybody, this particular date ring a bell to anybody? October 13th, Friday. 13일 금요일. Sounds like a title of a terror movie, right? Horror movie. But unfortunately, October 13th this year is Thursday, no class, so no possibility of quiz. So before I proceed, I'd like to tell a little bit about history. It's 1305. Clemens V is a bishop who was ruling Europe at the time. And he, on particular date, he ordered the arrest of a temple knight all over the Europe. That's the origin of the Friday 13th Friday. No, October 13th Friday. That dates back about 720 something, 17 years ago. That event happened, and it became some kind of ominous the date for the event. So it has nothing to do with the quiz, but just it reminds me of that particular date. So in last week we were talking about how to differentiate the vector field, the vector functions. And we like to talk a little bit about the integration today. So basically, integration is an inverse operation. So I guess everybody will be familiar with the mean value theorem. It's called mean value theorem. Well, maybe in Korean you can say 중간값 정리. So anybody heard about this mean value theorem? Raise your hand. 1, 2, 3, 4, 5, 6. And so this is entirely new subject for you, even though it's supposed to be covered in high school. Calculus in 수학의 정석. There is a chapter called 중간값 정리, blah blah blah. For example, we have a function x, y, fx. Say x square. There are two very important theorems in calculus. The first one is, of course, this mean value theorem. Second one is fundamental theorem of calculus. The fundamental theorem of calculus is nothing but if dx dfx is small fx, then nothing but fb minus fa. I guess you're also familiar with this concept, right? Nobody answers, so that means it's entirely new subject for you. The definition of integration as an inverse operation of differentiation comes from this fact. If we differentiate some big function f of x equal to small fx, then if we integrate this a to b, then the result is nothing but big FB minus big FA. So, for example, say A is x, B is x plus delta x, say, then A is B, x plus delta x, f of x dx f x plus delta minus f of x. According to the mean value theorem, this integral can be written as fx bar x plus delta x minus x fx bar delta x. So this is a second page. Someone put the footnote in my YouTube class that pity the student who has to read through my handwriting. I mean, somebody just said on my YouTube class, I noticed they say in 댓글, my handwriting is so bad, so students must have trouble. So, okay, I have so. After that, after reading the footnote, I read that footnote yesterday, so I'm going to try to write as clearly as possible. So, f x bar is delta x delta. Actually, this is delta x over f x plus delta x minus fx, and this is actually dx df. So fundamental theorem of calculus and the mean value theorems are interrelated to each other. So if one is true, then the other is automatically true. So let's talk a little bit more about so I will say FTC as an acronym. Acronym means 약어. Like when you say 고터 means 고속터미널, right? Or 신감 means 신세계 강남. Likewise, FTC means the acronym for fundamental theorem of calculus. And mean value theorem, MVT, as an acronym for mean value theorem. So there are several words ending with 님, like synonym. It's 동의어, right? Antonym, 반의어, acronym. So those are words actually came from Latin. Means word. It's Latin for word. Also, there is a word called script. Also means word, but it's from Greek. Same meaning, word. So if it came from, if the word ending with the name, it came from Latin, and it says word. So acro, sino, anto. Sino means similar. Anto means anti. If you say A to the B, what do you say in English? Superscript. 위첨자. Subscript. Great. Very good. 아래 첨자. So everything came from script, from Greek words. So if you know the origin of the word, you can actually know several other different words. Also, Holy Script, Bible. So it looks like my mathematics class became English class. But some of you may be taking TOEIC or something, right? Some English test as well. So if you know more words, that would be helpful for you. Okay, what was I doing? Okay, acronym for fundamental theorem of calculus and mean value theorem of calculus. So let's say let's go back to the original equation. Y is fx. Say we are going to integrate this function from 0 to 1. So integration is basically area covered by that curve. So fundamental theorem of calculus. But in this case, you can guess, right? fx is x cubed, right? So from FTC, sorry, no, F0, that is 1 over 3 x cubed 0, x cubed 0 is 1 over 3, right? Okay, let's cut in half, 1/2. Then f 1/2 is, so mean value theorem says f bar times 1 minus 0 is f bar. So if we set x bar as 1/4, then 1/4 is less than 1/3, right?
You can't see that part of the screen.
Oh, sorry. Maybe, can you? Still? You're welcome. Somehow the resolution in my iPad and the resolution in this project is different. So maybe a little bit enlarge. No. You can see, right? All right. So we have taken the wrong value. low battery. Thank you. So we have to be a little bit careful. So let me go back to next page. Okay. This is one. So we already know the answer from fundamental theorem of calculus. Says f1 minus f0 is 1/3, right? When thank you. dx dfx. By now, can I assume that you can differentiate any function? You can differentiate any function. Can I assume that? So you had, I guess, 2 years of calculus in high school, right? And probably the 1 year in the freshman years. So far you have taken 3 years of calculus, now. So can I assume that you can differentiate any function? No? So, because if you want to apply the fundamental theorem of calculus, we have to assume that we know something about differentiation. So, I guess you know how to differentiate x to the cube. I think in high school you just memorized 3x squared, right? But actually you can cube. You can how to expand this factor, right? You can multiply 3 factors. X cubed, 3 x squared delta, 3x delta square, delta cube. That part, I think you know how to do that, right? Up to now. So if you subtract, it becomes 3x squared delta, 3x delta square, delta cube. So if you divide, three x square plus 3x delta plus delta square. And then set delta goes to 0. What do you get? 3x squared, right? So this is true. I guess I still need to wake me up too early. So if we set x bar as 1/2, then f x bar square is 1/4. Maybe you can choose this part. 2/3. No, 2/3, 4/3. For x bar is 3/4. 16/9. This is larger than 1/3, right? This is smaller than 1/3. So we can say x bar is in between 1/2, 1/4, 3/4. More likely, exactly x bar square is 1/3, right? So x bar must be square root of 3. So it's more like 1.7 something over 1. Oh, sorry. Okay. So let's save the case for more complex functions later, but we just assume that two things are true. One is fundamental theorem of calculus and mean value theorem. Both are true. Or you have to have a faith. Either way is okay. See, if this is a math class, I'll try very rigorously how to prove that theorem, but this is mostly engineering. So engineers, we are using mathematics, not inventing or not investigating math itself. This mean value theorem can be extended to general cases. For example, we have A, B, C, D, F, X, Y, dx, dy. F, X bar, Y bar, B minus A, D minus C. So in this case, X, Y, B, C, D. So this is basically area. Or in 3 dimensions, A, B, C, D, E, F, F, X, Y, Z, dx, dy, dz is F, X, Y, Z, P minus A, T minus C, F minus E. So we have a little parallel pipe. So AB, CD, and this is FE. So this is a volume, and we call this parallel pipe. Parallel pipe. parallel pipe. 육면체. So this is a preliminary knowledge we need to do the vector integration. Maybe I should shrink it a little bit too. Okay. This is going to take a little while, so we're going to do this very interesting integral. Perhaps you can take a few minutes break and then continue. What about that? A, B, C, D, and let's say this distance is delta x, delta y, say center as xy, baba. So this is 1, 2, 3, 4. So in the subsection 1, dl is in the direction x bar dx. Again, this is delta x, this is delta y. Then f dl is fx xyz dx, right? So the center is x, y. Let's say. So actually, assuming that this distance is delta y over 2, so we have to change this into y minus delta y over 2 dx, right? So if we integrate to a to b, it's basically, you can say, f x bar y minus delta y over 2 z delta x. This is it. We have applied mean value theorem. I have to learn how to make copy. Let me try. Okay. Oops. Okay. Maybe I can copy this. Oops. Okay, I have to draw it again. Let me just try again. If without copying anything. How can I make a copy? I rather. That's correct. So everything comes with the fact that I can copy the whole screen. So I promised I'll try to figure it out. But I didn't keep my promise, but I'll still do. Oh. And am I loud enough? Also, I didn't know how to delete the page. Let's see if I... Nothing is copied. Okay, I have to do it again. This is 1. Now this is 2. X, Y, Z. This is x, of course. This is z. So this is xy plus delta y over 2 z delta y delta x. Along 2, its direction is opposite. So dl must be, direction is minus x, right? dx. So f dl is minus f of x, x, y plus delta y over 2 c dx. So if we integrate, this is a, b, c, d, c to d, c to d is minus fx x bar y plus delta y over 2 z delta x, right? Second screen. So 1 plus 2, we have minus fx x bar y plus delta y over 2 z delta x plus fx x bar y minus delta y over 2 z delta x minus fx x bar y minus delta y over 2 z my handwriting is a bit horrible, so minus fx x bar y bar del over 2z. So let's say third screen, we have I don't have enough space. Next page. So this is 3, right? 1, 2, 3, 4. Let me see. I made a mistake. I'll try to figure it out. 1, 2 means we have f of x, x bar y minus delta y over 2z minus fx x bar y plus delta y over 2z z delta x, right? I think last time I told you that in mathematics you can do nothing by multiplying by 1 or add 0, right? So this is basically the same as you divide by delta y, fx x bar y plus delta y over 2z fx x bar y delta y over 2z z delta x delta y. So it's basically partial y, partial fx, x bar, and we can say without change z delta x delta y. Some arbitrary value. Actually, we can change this later. So y z so this is x y, this is delta x delta y. So you can actually change this minus partial y partial fx dx dy for this is delta s. Yes. Now we can do the same thing for, let's say this is 3. Oops, it was now 1, 2, 1, 3. So for 2, this is again x, y, center is x, y. For 2, dl is actually y direction, dy, right? So f dl is here, fy, x plus, this is delta x over 2, yz, dy. If we integrate a, b, c, d, b to c, f dl means fy x plus delta y x over 2 y bar z delta y. Again, we apply the mean value theorem. How about 4? dl is minus y dy, right? So in this case, fdl is fy x minus delta x over 2 minus yz dy. So c t to a f dl is fy x plus delta x over 2 y bar z delta y minus fy x minus delta x over 2 y bar z delta y. Oh, 2 plus 4. Same as y x minus delta x over 2 y by z delta y, and you divide by delta x and multiply by delta x delta y f y partial x partial fy delta x delta y is actually partial x partial fy dx dy. So 1 plus 2 plus 3 plus 4 means you integrate f dl, and let's say this is for closed loop. So this denotes for closed loop. Means this looks familiar, right? So what is this? Z component of coils F, right? Z component. Or you can write this way. This is a very special case of a call in Z direction because we have X and Y, Z. So we have this small area, and Z is normal to the surface in XY plane, right? So in this case, Z normal to the surface in XY plane. Copy. Oh, you need to. So we can actually generalize we have a surface x, y, z plane. So n is a normal vector. unit to the surface S, and say somehow we can define this line integral This is called the Stokes theorem. So I have actually in this class, I have shown particular case of Stokes theorem for XY plane. So maybe I'll give you homework. Show Stokes theorem in YZ plane. So you just do it at home. And Stokes theorem is probably the most important mathematical theorem discovered so far. So one of the applications is Faraday's law. You are going to learn this Maxwell's equation. Let me say, let's check the Wikipedia for when the Faraday invented electricity. (1821). So Faraday in 1821 have done the following experiment. He formed a closed loop over with the metal, like copper, and then connected at two ends to the voltmeter. And then he moved the magnet up and down through that coil. So it's closed loop called coil, copper loop, coil. So at the end of this electric loop, if you integrate electric field along the line, you get voltage, right? This is magnetic flux. So 1821, to Michael Faraday discovered that if you move this magnet up and down to this coil, that changes the magnetic flux, right? So this magnet generates magnetic field, B field, generated by this magnet. So if you move up and down of this closed loop called the coil, then he discovered that this integration of magnetic field along the surface, called the magnetic flux, changes with time, because it's a moving magnet. Then discovered that there is a finite voltage difference between this coil. So that means from this Stokes theorem, if you integrate this electric field along this line, there's a difference in the voltage here and there. That means if you have a voltage difference in closed electric loop, it means current can be induced, right? So magnetic field, Michael Faraday discovered that time change of magnetic flux that means moving magnet produce electric current. That is a very important discovery. So 1821, Michael Faraday just discovered that from Maxwell's equation, this is one of the Maxwell's equations, that if you change the magnetic flux in closed loop, that produce electric current. So that is basically the invention of electricity, right? So that led to the invention of electricity. This is a very important event in maybe our civilization. So before, after. So I think our civilization can be divided by the era that we didn't have electricity before, after, right? So before electricity, what happens? No lighting. We have to use a candle. Of course, no cell phone, right? Without electricity, there is no cell phone. So the date, 1821, is a very important thing in human civilization, that basically, before that date, or after that date, we have artificial meaning of generating electricity. And that led to current modern world, right? Before that, maybe before 1821, our life was not much different from 10,000 years ago, right? Of course, there is a slight difference. We invented wheel, we invented gunpowder, so we can effectively kill more. Also, we invented the magnet, compass, so we can navigate, but that's all. But after we learned how to produce electricity, everything changed so rapidly, so that led to vacuum tube, transistor, and et cetera, to the modern world, maybe even to the quantum computer as well. So I would say Stokes theorem is probably the most important mathematical theorem ever invented in history. We are going to learn another mathematical formula as important as this Stokes theorem, but the Stokes theorem is basically the basis of modern world. The Faraday, if we filed a patent for this, I think he would become extremely rich. But he didn't. So that everybody can use the generators to produce electricity. And so Faraday basically discovered the idea of how to generate electricity. And do you know who commercialized this idea? So Faraday actually wrote a paper, journal paper, that the changing of a magnetic flux produced electromagnetic force, electricity, in 1821. But who actually commercialized this idea to build the factory to generate electric current? You know this very, very famous name?
Tesla? No?
Edison.
Edison?
Right. So he founded General Electric, Thomas Edison. He commercialized his idea, and GE. And he filed a tons of patents of how to design the generators. So he made a lot of money. He was not very good at mathematics. Faraday was really good at mathematics. But Thomas Edison knows how to patent the idea. I think you are engineers, so you have to learn to do something. But this is one of the reasons that we are learning mathematics, because the mathematics allows or generates new ideas that can become a new technology. So I wish you get familiar with the idea of Stokes theorem and how it is related to the electromagnetic field, especially the Faraday's law, and how it is related to the the generation of electricity and how it actually sparked the direction into the modern world. So the Faraday changed everything actually. So first person is Isaac Newton. His most precious invention is calculus. We know that, of course, Newton formulated mechanics, classical mechanics, and gravitation, etc., etc. So the founder of classical physics. But he is also founder of mathematics because he invented basically calculus. And his idea of calculus led to Maxwell and Faraday to found the formula such as Stokes theorem, it is very unfortunate because the basic idea of calculus was already in the Greek era, in BC, 4th century to BC, 2nd century, like Pythagoras era, Pythagoras. So there is a unproven story that the Greek knew the calculus. But destroyed during the big fire in the Alexandria library in around the beginning of this century, beginning of the AD. So almost 1800 years was forgotten, spent, gone, and we had like a dark age in our history for almost 2,000 years without utilizing calculus, etc., etc. But last about 400 years after Newton either discovered or rediscovered the calculus, and then it became very, really fast. So it took only 300 years from Newton, 250 years from Newton to Faraday, from the basic calculus to Stokes theorem, and it led to the modern civilization, modern technology. So we don't know what will happen in the future too, because that's one of the reasons that you need to learn mathematics. Because you may be one of those Faraday, next Faraday, who are going to invent a new technology. Okay. That's about the Stokes theorem. So maybe you can take a break a little bit and then go to the next topic. Okay, let's continue. So this time we are going to do three-dimensional vector integration. So let's limit our focus to cube, not parallel pipe, because simple things. X, Y. So how many surfaces that cube has? 6, right? Cube. Say 1, 2, 3, 4, 5, 6, right? So say 1, 2. So let's say as before, center as x, y, z. So on 1, say we are interested in doing f dot n. N is a normal vector. Unit normal vector to the surface. So in surface 1, the direction of the normal vector is in z direction, right? N is same as z. So n f become f over z x y z plus delta z over 2. So say this is delta z, delta x, delta y. We can do the same thing as before. So if we integrate ds dx dy, right? So one is this is one, surface 1. So this is dy dx. So surface area is dx dy. Normal vector is z, right? The same as f z x y z plus delta z over 2 dx dy. Using mean value theorem for 2 dimension again, we obtain fz x bar y bar z plus delta z over 2 delta x delta y. On surface 2, on the other hand, n is in this surface minus z direction, right? One is this way, the other one is in the downside, downward, so it's minus z. The surface area is still the same. Minus c. ds is still dx dy. So f and ds is minus fz x bar y bar z plus delta minus delta x delta y. Here we have x, y, z minus delta z over 2. Here we have x, y, z plus delta z over 2. So 1 plus 2 is basically fz x bar, y bar, z plus delta z over 2 minus fz x bar, y bar, z plus delta z over 2 delta x delta y. The same as you can actually divide by delta z and multiply by delta z, right? So it becomes partial z, partial f z, x bar, y bar, some average value of z, delta x, delta y, delta z. And then you can transform back to like three-dimensional integration. dv using mean value theorem again. And you can generalize to other cases. So let's move. It's time to copy. Yes? Sorry. So this step is just do nothing, right? You divide by delta z and multiply by delta z. It's basically 1. And the center is x, y, z. And let's say this time two different surfaces. So this is called 3 and this is 4. So on this surface we have this one and x plus delta x over 2 y z, and on 4 x minus delta x over 2 y z. So in surface 3 we have f normal vector is in which direction? X direction, right? So on the surface 3, this is normal to the surface, so this is in x direction. And ds is dy dz. dy dz. So f and ds is basically fx x plus delta x over 2 yz dy dz, right? So if we integrate this, using mean value theorem, you got still x delta x over 2 y bar z bar delta y delta z. On the other hand, in surface 4, n is in minus x direction, but still ds is same as dy dz. So f and ds is minus fx x minus delta x over 2 y bar z bar delta y delta z. Right? So 3 plus 4 means we have fx x plus delta x over 2 y bar z bar minus fy x minus delta x over 2 y bar z bar delta y delta z, and then you can divide by the whole thing by delta x delta x. Then we obtain partial x partial fx x bar y bar z bar delta x delta y delta z is partial x partial fx dx dy dz, or three-dimensional integration dv. And you can see the whole thing, right? So we have done 4 surfaces so far out of 6. But we're expecting we would get the similar result, right? But let's just double check, nevertheless. Just one more page. So So 1, 1. So let's say this is 5, this is 6. Of course, center is x, y, z. Here, x, y plus delta x over 2, delta y, z. Here, x, y minus delta y over 2, z. So on 5, ds is, of course, n is y, right? And ds is dx dz. So fy x y plus delta y over z, 2 over z, dx dz. It's not mine. So if we integrate using chain rule, mean value theorem, x bar y plus delta y over 2, c bar delta x delta z. On the surface 6, we have n minus y direction, ds dx dz. So f n ds fy x y minus delta y over 2 z dx dz. You integrate fn ds minus fy x y minus delta y over 2 z bar delta x delta z. So if we do that together, maybe it still needs time to copy, right? Five plus 6 then we have y x bar y plus delta y over 2 c bar minus f y x bar y minus delta y over 2 c bar delta x delta z, right? So since we have more space, I can use one more line, delta x f delta y x bar y plus delta y over 2 c minus f y x bar y minus delta y over 2 c bar delta x delta z delta y, right? So this is basically partial derivative. Partial y, partial f, delta x, delta y, delta z is partial y, partial f, dx, dy, dz, dv. So far we have opposite faces separately, and now we can combine all three results together. Closed surface integral. So all three surfaces. 1 plus 6, 2 plus 4, 5, 3, 6, right? Then partial x, partial f, partial y, partial z, partial f, z, dv. It's s and v. So this expression must be familiar, right? This is called divergence of f. So this means So it does have a name too. It's a Gauss theorem. The Gauss theorem has a so one of the integral in the that means if we integrate dv total charge so for example, we are not learning the spherical coordinates yet, but this is general case. So if we have a sphere with a radius r, what is the surface area? 4 pi r square, right? Times electric field. Permittivity of electric field. This is called unit direction. Say R. So we are going to learn this later, next week, but I'll just put this as total charge Q. So electric field is 4 pi epsilon R square over Q. So far today we have learned two very important theorems. Stokes theorem. The other one is divergence of f dv. There are other topics, but you must be hungry, right? So perhaps I will stop today here and continue next week after quiz. So the quiz is up to now. So for example, before I stop, simple example. Say we have a volume, total volume is 1. And F is XX, yy plus cz. So what is the result of this? What is divergence F? 3, right? So this is simply 3. The actual calculation of the surface integral can be complicated, but if you want to transform into the volume integral using Gauss theorem, you can get the answer very easily. Okay, so let's stop here today. Oh, you can still